would say divided answer is first strongly that's the only measure what we're confident this is our off the magic number.
I guess we'll survive.
Yes, we will.
I guess I can watch the jabber from here.
Yeah, it'd be good.
I'll watch the Zulu. Did Anna do a mic check?
I'm sorry.
Did Anna do a mic check? She's asking. Is she not
I
here?
heard Anna talk,
Okay,
so
we're good then.
I heard Anna and Gory have a discussion, so they're all set.
All right. Just a mic check.
Okay, Louis, you're gonna be presenting remote.
Yes, I'm going to present the meeting.
Okay, and your mic works. Anna,
Okay.
let's quick check. Does your mic work?
Can you hear me?
We can hear you. Thank you, Anna. Okay, excellent. Let's do a few more quick checks here. Marcus, MPDCCP, are you here? Yes. Okay, he's waving at us. Thank you. Sorry, I apologize for what I'm about to do here, but I cannot recognize anybody behind a mask. So we've checked Gory and Anna. They're here. I'm looking at Greg, so he's here. We just checked with Louis. Some of your long-term work group chairs handle that item. The CAN drafts. Peng, are you here? Okay, that's the very last item in the meeting. We'll deal with it and mic checks if and when we get to it. Okay, so Magnus, you're gonna take notes. Can we get one other note taker, please? Do I need to start going around those who took seats up at the flat tables and figure out? Thank you, Martin. And the job isn't voluminous notes. Please, we're mostly interested in capturing important things said at the mic and important conclusions reached. And with that, let's go ahead and get started. This is the Transport Area Working Group at IETF 114 in Philadelphia. Your work group chairs are Gory, who is remote out there somewhere. There he is, waving at us. I'm David Black, and this is Wes Eddy. Okay, this is the note well. You've seen it before. You'll see it again this week. I'll make sure you've read it at some point. It applies to you. Okay, we have a note taker. In general, folks, the working group runs on reviews of drafts. Please, if you find a working group draft that's interesting, review it, send comments to the list. The authors are almost always grateful. A reminder, in general, if you want to draft brought to the attention of TSVWG, put TSVWG in the name of the draft in the usual place. Meet Echo Mic Cube. Please click the hand icon to join the mic queue and wait to be recognized before clicking your mic icon. You'll notice your work group chair just set a lousy example by not doing that during the mic test. We had good reason for that. Okay, I said earlier, document quality relies on reviews. If you'd like documents you care about reviewed, please review some other documents. UDP options and multipath DCCP are a couple of documents that would benefit from some thorough, detailed reviews at this point. The design work is pretty much complete, and it's time to go over the details and make sure we've got them all right. Okay, accomplishments and status. And as part of this, this is going to be the updates on working group drafts that don't have a slot on the agenda because we just need to tell you what's going on. Okay, one RFC has been published since IETF 113. That's the new SCTP document. Thank you, Michael, for getting through that. We have no drafts to the RFC editor. The L4S drafts have completed IETF last call. There's 3 of them. Issue resolution is in progress. You're seeing it on the list as Bob and the author team respond to the inbound comments that they've received. I think you working through the area reviews is going well. Yes, Bob?
Hi, it's Bob Briscoe. I'm editor of all 3, and so far everything's been resolved that's been sent, but there were 12 reviews lined up, and I've only seen 3, so I don't know how long we wait before I issue another draft.
I think you get to make the call. When you think you've got enough material done that we ought to issue another draft, issue another draft. Ultimately, decision on whether to wait for the reviews rests on which reviews to wait for rests with our AD, who is now nominally responsible for the draft.
Okay, I'll have a chat with him.
Okay, and I want to say thank you to Valerie Smith-Slav, whose last name I probably just butchered, because I thought the discussion around that security review was a great example of how things ought to happen when there are some solid technical issues raised. Okay. We have 2 drafts working group chairs and authors after working group last call, where they're with me. These are the ECN encapsulation draft. When Bob comes up for air from working on the L4S drafts, we have a little more text to write for one of these drafts. The reframing interaction text is mostly right. We just have a slight problem about making sure it's clear when reframing happens. It's interaction between sections 4.4 and 4.6.
Hi, it's Bob Briscoe again. I did come up for air half an hour ago and sent a couple of emails to the list, which you've probably not seen yet.
That's correct.
Okay, so yeah.
You're capable of multitasking. This is really good.
Yeah, some more text is needed, but I detect it's going to be more along the lines of we can't disagree, so we're just going to agree to disagree, and this will have to be sorted out later.
I will take a look at it. I believe before you sent those emails, my impression was we just need a little bit of scoping text to explain when reframing happens and when you have to do the congestion accounting as part of reframing. And with luck, we'll get there. Okay. One draft just completed working group last call, assigning a new recommended DSCP. That one has an agenda slot. You'll see that shortly. Remaining working group IDs, and this is where we do the low flyby to explain what's going on here. Okay, L4S operational guidance. Greg says that one's in pretty good shape. It says the star here is something I need to update. We took it off the agenda. And it's going to be a living doc. I think we're going to keep it alive for a while as people move forward with hacking on L4S and getting it to work and getting it deployed. Greg.
Yeah, I just also wanted to add that It is effectively a living document at this point. So as deployments start and we gain experience, I, as the editor of the document, would love to hear things that the document is missing, some things that we could add to improve to it. It's already a product of many inputs from many individuals, but the expectation is more will come in. So please feel free to contact me or the list if you think there are things that we can add to improve that document.
Okay, great, thank you. Non-Q building, NQB, PHB, that will have an agenda slot this afternoon. UDP options and datagram path MTU detection for UDP options. Gore, you want to say a word or two about those?
Sure, yeah. Both of the UDP options drafts are simply waiting for Joe to say this is the last version that he wants to put to the working group. I believe that all the issues are known by Joe and the text is pretty much there. I'm just waiting for Joe to say it's ready.
Okay, sounds good. DTLS SCTP continues to move forward. We know we have to publish the new version of it because 3GPP needs it to deal with large search chains. SCTP NAT is expired. Gori or Michael, any words of wisdom on that?
Is Michael wanting to comment? Go ahead, Michael.
So can you hear me?
Yeah.
Yes, we can hear you. Go for it.
Yeah, so I had some discussion with, I looked at again at the feedback from the former Transport AD and the current one, and basically the way to resolve most of the issues are removing any STTP specific thing from the document and just do translate the IP address, but don't translate the port number. That seems to be the simplest way to address both of their comments. I also chatted with Claudio, and he sort of agrees. They are focusing on what's available right now, and then the question is whether we really need a document describing the obvious thing or not, because the core of the SCTP NAT document was how to do it in an SCTP specific way to deal with not being able to change the port numbers. Another one was someone contacted me and said that it's almost impossible to deploy a NAT without being able to change the port numbers and without being able to be DOS attacked easily. I tried to contact him and figure out what the way is. So that's why I'm not sure if it's worth reducing the document and spending the effort or just drop it.
Magnus at the mic.
Yeah, a question for clarification here. When you say, I understand that the NAT specification part might be the simplest, just do nothing special at all. What about the SCTP parts? Those recommendation part of how you actually deal with that? Are there nothing left of that?
I mean, what you do is you change. If you don't change the port number, you just change the private address. What is specific? I mean, the only specific thing is that you can't change the port number, but that should be obvious.
Yeah, but
so
I mean,
all the other stuff is how to deal with take the verification tag into account and deal with port number collisions.
Yeah.
And you said, well, that affects endpoint behavior. That is difficult to implement, and
Okay.
basically the same major points came from Martin, and they are valid. So it's
Okay. Sounds like we probably ought to take this to the list with the notes reflecting that that the value of a draft that only does the IP address translation, doesn't contain SCTP specifics, is unclear. But I think we need to move along here in meeting time. Thank you, Michael. Thank you, Magnus.
David, I think I'd be happy to see a simple document if it was going to really be used. So there's no bar about how simple it can be if it's really used. But you guys need to talk a bit more before we get to that decision.
All right.
So happy to take it to the list.
Yes, please. Take it. Let's take it to the list and make sure the minutes reflect that the value of the draft is unclear. And I think Gory is heading in a good direction, which is if it's going to get used, we got to document it. But let's make sure we can actually write up something usable. Multipath DCCP has an agenda slot later. Related IDs to the working group. These are all individual drafts. User reports for experiments. It's on the agenda for later. We'll talk about it then. Enhanced port forwarding functions with CGNAT also on the agenda later. We'll talk about it then. There's a draft WANG THWG SWSLC FEC scheme. It's been posted to the list. We've not seen any interest in it. If you're interested in this draft, please post the list or talk to the chairs about it. It's not on that one is not on today's agenda. Milestone review. Okay. The two milestones here that say April, those milestones are about to be achieved. So I'm not going to go work on putting new dates on them. I'm going to guess that between Bob and myself and the folks on the list, we'll probably have those drafts submitted sometime next month or by sometime in September at the latest. Gory, can you reach out to Joe and between the two of you figure out what the dates ought to be for the UDP options draft? Thank you. Everything else is still on course one way or another, although we'll talk about the first two drafts, NQB PHB, we will talk about in this meeting. SCTP NAT support you just heard about. In considerations for a new recommended DSCP is on the meeting agenda. Next year, DTLS over SCTP, multipath DCCP, and right now we have a July 2023 tentative date for L4S ops. That one's very, very malleable. We can easily make calls as we go along as to when is the right point at which to close the material and publish it versus keep it open because interesting things are being learned. Okay, so having done a trip through the working group's program of work, let's go look at the agenda. So these slides are the agenda. We just did the milestones review. Chairs update these slides. We've just managed to get through ESA encapsulation draft status, LFRS draft status, and active working group draft status in general. We have 4 working group drafts, 4 sessions on working group drafts. Mark is going to talk to us about multipath DCCP in a couple minutes. Anna and Gory on considerations for assigning new DSCP. Greg White on NQB and the L4S interop update, where good things have been happening around here. Then we get individual drafts. The chairs are going to talk about user reports for experiments. Heads up, folks, to explain what is going on here. This is a process draft that has basically come out of the ports review team about something they think would be very useful in terms of managing ports. We're probably going to move fairly quickly on it. We'll have more to say when we get this agenda item. Then we have enhanced port forwarding functions with CGNAT. And if time permits, computing aware networking drafts. The items up to item 4.2 are normally budgeted for 1 3/4 hours of our 2 hours. We'll see how things go when we get there and how much time is left for those drafts. Would anybody like to further bash the agenda? Going once? Going twice? Consider the agenda bashed. And now for something completely different. Wes.
Or Martin.
All right, we can do it this way.
Yeah, Wes Eddy was brought on as Tsvwg chair quite a bit before I became AD, but specifically as a third chair to help with the very administratively intensive L4S process that we're all aware of. Many of you just heard the spiel 45 minutes ago in TSV area, so I guess I could be brief. But Wes, thank you very much for all you did to make that happen. It looks like it's going to be a successful process, and it's out on the internet. Wes, since mission accomplished now, so he's going to step down as TSVWG chair after this meeting. And I'd like to thank you on behalf of the community for everything you did, both there and in really other things. I mean, you weren't just the L4S guy. You certainly lended your expertise to everything going on in the working group, and it's very much appreciated. So thank you very much.
Thank you.
And to be clear, TSVWG is going to then go to 2 chairs.
Okay, and then the rest of what's not yet on this slide is, this is David. I am going to be stepping down as a working group chair after the next meeting in London. So the game plan is that Martin's going to see about finding another working group chair. Yes, and then Gory, that new chair, and myself will make London happen, after which I'm going to step down. I have been a chair for quite some time, helped a number of drafts along. It's been an adventure. It's been a pleasure. Thank you to everybody who helped. All right, Marcus, I think we're on to you. Let me see if I can make this put your slides up. You should be fine. Just tell us when to advance the slides. I think I have to do it from here.
Okay. Yeah. Hello, everyone. Marcus Arment, presenting progress on MPDCCP on behalf of the authors. Next slide, please. Yeah. First, starting with the status update. So what has changed since last IETF? We made a version bump from version 4 to 5. And committed a lot of changes to our GitHub repository where we maintain the multipass DCCP draft. You see at the bottom a link to the full changelog. I think it was more than 100 commits this time. We organized everything as pull requests. A number of pull requests addressed editorial work, as you can see on the top. But we also made a lot of changes regarding our multipath features we have defined for multipath DCCP. That was mainly based on implementation feedback we received. So, for example, redefine the MPRTT age parameter to specify the actuality of the MPRTT measurement, of the RTT measurement we convey in the MPRTT option. We added a new section on closing procedure. So we give a description here, also accompanied by some diagrams. Along with that, we enhanced the MP close definition, including connection and subflow socket states. So we give really in detail some overview to which states the socket moves. We clarify address ID usage. Here I have to admit that we more or less took address ID definition from the MPTCP RFC. So address ID is used, for example, to persist in nutted environments where original IP addresses are not visible. We extended MP prior definition. That was a long-lasting discussion between the authors, I think, since 2 IETF meetings. The MP prior is a value of 4 bits, where value 0 means a path shall not be used for scheduling purposes. I think prior value 1 is to put a path into standby mode, so it's only used when there's no other path available. And then we have value 2, which defines a secondary path, and from value 3 onwards, we have a primary path definition, and you can use value 3 up to 15 for giving priority information to the scheduling process. We updated IANA section, proposing there multiple things to be registered. So that are MP, the multipass options, a new DCCP reset code we use for closing a multipass DCCP connection, and last but not least, also the key types we use in the MP key during the handshake of a multipass DCCP connection. We enhanced the fallback section, where we also now include version, MP key, and checksum mismatch and its impact on either the MP DCCP connection or individual subflows. Yeah, and the one I think what I would like to highlight here is enhanced description and secured multipass, add address and remove address. So for those of you who are familiar with MP TCP, there's also add address and remove address specified to add new subflows or to remove subflows when interfaces, for example, coming up or going down. Different to MP TCP, I think we secured both add address and remove address, so that only the multipass DCCP client and server are able to generate and exchange those information, and no man in the middle can generate or make use of those options to impact the multipass DCCP connection. Next slide, please. Yeah, maturity state of the MP DCCP. So as we already announced last IETF, we freezed the feature state. So we do not expect that any new multipass option will be specified. We are pretty much convinced that we have everything which is required for a successful implementation and usage. So focus is now on, as you have already seen in the introduction slide, on editorial fixes, incorporate more feedback from external review. For example, Matt Bucadera has already made a great job and gave a very comprehensive feedback, pull requests and issues. You'll find the links at the bottom of the slide. We expect more external review quite soon, at least people promised to us. And where we also focus on is on clarifications and design improvements based on prototype implementation. You will see in the next slide that we are heavily working on completing the prototype and incorporate all the multipass options which are specified in the draft. And the feedback we get from this implementation helps us to improve our MP DCCP draft. Next slide, please. Yeah, that is exactly the slide I reference to. So this gives an overview again on what is completed in the draft, what I also outlined throughout the last two slides. So where we put some focus on this time, so in this current version 5, is to complete MP RTT, add address, remove address, MP prio, but also fallback mechanisms and MP close. Most of them due to our work on the prototype. And if you look into the prototype column, you see that more or less everything is now incorporated, available in the prototype, this Linux reference implementation we have of the MP DCCP. So where we put a lot of effort in is to implement MP add address, remove address, and also MP prio. What we improved in our prototype implementation, because it was not fully implemented, was the MP join, which did not cover the address ID, and the MP RTT, which where the type and age parameter was missing. So that is completed now. You also find here in the slide the individual pull requests in our public GitHub repository where we maintain the reference implementation. We have started now to implement also the MP confirm. MP confirm is used for a reliable exchange of multipath options. So far in the draft, this is defined for add address, remove address, and prio. Yeah, which is still missing is to have all the fallback mechanisms implemented. And what is completely missing is the fast close and the close. Our goal is to complete all these missing things until next IETF in London. Nevertheless, we are happy if someone contributes to our code. So all the informations are available in the draft. And we also have a website, multipassdccp.org, where you'll find the relevant information to contribute or to use the MP-DCCP prototype. Next slide, please. Okay. Giving some more status information on the reference implementation, more or less, that is something what I already presented last IETF, but I think it's worth to repeat it here. So the published prototype is for sure providing MP-DCCP as it is specified in the current draft, so the multipath transport protocol itself. On top of this, we also provide some more implementation to make it also usable in other scenarios, so not specifically for DCCP transport, which is for sure the main target, but with the encapsulation framework we provide on top, we are also able to transport non-TCP traffic and make it multipath capable. We have a number of scheduling algorithms available. You see them on the list on the left. We are able to compensate the path latency difference. Imagine you use two paths with different characteristics, in particular different latency, then it's pretty likely that you have to compensate for these latency difference. Here we have implemented reordering mechanisms to deal with that. We have different congestion control algorithms in place. CCID 2 and 3, what we typically use for multipath DCCP, but also a new one, the CCID 5, which adopts BBR principle. We try to drive this in ICCRG, but I think from the previous TSV area meeting, yeah, we all know that this is at the moment a little bit difficult to drive new congestion control mechanisms. So let's hope that this will be solved soon, so that we can really specify CCID 5, which we think is very valuable for MP-DCCP. And last but not least, we are also able to establish and destruct subflows during operation. All of this, for example, helps us when it comes to adoption of MP-DCCP in frameworks like 3GPP, ATSSS. I will not go into detail here, but it's quite helpful to have all these additional functionalities on top of MP-DCCP published, and makes it quite usable in many, many scenarios. So all these is available since last IETF, where we presented this, so please make use of it, especially the adoption into Android and Linux-based devices should be quite simple. The 7 selectable scheduling algorithms, we also are convinced that they enable a range of use cases and can be used to demonstrate the effectiveness of multipath DCCP. And an announcement, so we plan additional reordering mechanism to be published using MPRTT for dynamic path latency difference determination and equalization at the end. Next slide, please. Yeah, some general updates from the MP-DCCP ecosystem. I think that is also something what I presented in detail last IETF. So MP-DCCP is proposed as a so-called lower layer solution to the ongoing release 18 study phase on ATSSS enhancements. So we matured these lower layer solution, and you find latest update in version 0.2 of the technical report linked here on the slide. Some interesting work we also did, or people did when they used MP-DCCP to demonstrate the bad effect of multipath latency difference on end-to-end services to queue reordering. That was contributed also to 3GPP, a discussion around the ATSSS. So again, if you have multiple links with different characteristics, and you use multipath DCCP or a solution like multipath quick using mask and datagram extension, which is also discussed as an alternative for the ATSSS, then you have this challenge of having packet scrambling introduced when you simultaneously use a path with different latencies. That's quite bad for the application or end-to-end services using tunneled multipath. and we were able to prove that in-network reordering mechanisms are required, so probably something what has to be specified in Tsvwg. So MPDCCP prototype was used for that. A number of results are available. We will present those results during ICCRG slot on Thursday. And what we especially verified, how the impact on quick end-to-end, but also the effect on traffic using different congestion controls end-to-end. So quite interesting work, and I encourage you to listen to the ICCRG presentation. Yeah, OEM will start MPDCCP smartphone integration in September. That is what this OEM told us, with focus on interoperability with MPDCCP proxy. And also because 2 universities reached out to us asking for some help to setting up MPDCCP to get it compiled and so on. So that they are looking into MPDCCP, and one of them we know is looking into MPDCCP for vehicle communication. Next slide, please. Yeah, coming to the question, is there any feedback from the audience?
Any questions?
So if there's no question at the moment, maybe I have a question to the... okay, Gori, go ahead, please.
Go, Gori.
Well, I was going to try and answer the question on the slide, which I think probably goes to the working group chairs. The charter, I think, says July 23. That's the target. If we can beat the target, I'm okay with this. So let's talk after this meeting about how mature these are and where we've seen reviews, and we can start working group last call when we are ready, which might well be IETF 115 if all the things are right.
Okay, thank you.
I mean, this is David as working group chair. I'm noticing that the whole discussion is now at a much more detailed. These smaller things are getting done. We think we've got the graph functionally complete. So yes, I think it is getting very close to the point at which working group last call makes a lot of sense.
Okay, thanks.
Any other comments? Okay. Hang on a minute. I need to look at my cheat sheet. DSCP, Anna and Gori.
Yeah. Hi. So
Go ahead,
hello.
Anna.
I'm here with the latest update of our draft versions presented in DSCP. So for those who don't know, this draft aims to give an overview of what observed mappings exist out there in the internet that are potentially DSCP assessments. Since last IETF, our document has gone through working with we received lots of comments and have just the other day uploaded a new revision, which we think addresses all of them. Next slide, please.
Anna, we're having a little trouble with your audio. If you can reduce your mic volume or mic gain, that might help.
Okay, give me one moment. Hi, can you hear me now? Is it any better?
Oh, that's much better and much clearer. Thank you. Thank you.
Perfect. Sorry about that. Right. So thank you to all the people who reviewed, in particular Rudiger Geib, who's raised many issues. The two major issues we had were that the document was not clear in its scope and intended audience. So we clarified that it is not intended for application developers who want to choose a DSCP, but rather for the IETF and IESG when dealing with a request for a new DSCP. So this is included in the new revision. And we also reworded a paragraph about networks which follow RFC 8100 to avoid any implication that RFC 8100 is not compliant with the DiffServ architecture. Next slide, please. There have been 17 minor issues raised as well, and I've included here just the highlights. We made extensive use of the word pathology to describe observed remarking behavior, but there was a slight medical implication here that there's something wrong with this remarking, which is not the case. So now we use just observed remarking behavior instead of pathology. Similarly, we mentioned non-DiffServ aware routers when what we meant was non-DiffServ aware remarking, and that's now reflected in the text. We now also cite RFC 3086 in connection to DiffServ domains, and we've made sure to distinguish between DiffServ nodes and DiffServ domains as well in the text. Then we've incorporated some text from Rudiger on mappings specified by mobile and MPLS standards, and now those sections are a bit more in depth. And finally, we're now referencing the right RFCs in connection to network control traffic, and also wherever we use the term service class, as the term was already defined in a couple of other RFCs. So the issues that I'm presenting here are not exhaustive, but you can see all of them on the GitHub page for the draft. All of them are editorial changes, language and reference clarifications. Next slide, please. So while we were looking at some of the older RFCs that we referenced in the text, we found some interesting text here in RFC 4594. It describes a local use for code points that have the three most significant bits 0 and end in 1. So in decimal, that means code points 1, 3, 5, and 7. This local use, as I understand it, was proposed for networks that used IP precedence, I think because of concerns around the code running equipment at the time. But since then, code points in pool 3, which includes the one I've just mentioned, were assigned to standards action, and then also code point 1 was assigned to lower effort. So going on to the next slide, please. Here's a question for everybody here. We want to add a footnote that mentions and describes, essentially reflects this text. So here is the proposed text that we have on this slide. It mentions this local use described in RFC 4594. Is there anything here that you see that you object to with regards to this text? If so, just let me know at the end of the slide deck. I'll go back to this one. Also to clarify, the assignment of DSCP5 and the discussion around that is not in scope for this draft. So next slide, please, which is just the final slide to say the new revision has been uploaded. Check it out. If there are any issues or comments, we welcome them either on the mailing list or here's a GitHub link where you can submit them. And thank you for your time. We can go back one slide so that the text that we were just proposing is in focus, and then I'm very happy to take any sort of comments or questions or anything else. Thank you.
So this is David. I think you found something, and I'm not sure what to do, but I think it is important to recognize that we now have a recommended use for DSCP1. And so I think a note saying that things have changed since RFC 4594 is probably in order, and I don't want to spend the next 15 minutes trying to wordsmith it. But I do think you found something there. Good catch.
Okay, then I guess we'll work with the document shepherd to include this text in the RFC. Well, in the draft. Thank you.
Okay. Bob at the mic, and then Jonathan. Bob.
Bob Briscoe, wouldn't that imply that we ought to do an erratum to say that the new use of it ought to have updated the previous text or something like that.
Let's take a careful look at it. Um, taking the lid off of RFC 4594 might, in some ways, might be taking the lid off Pandora's box. Let's make sure we think very carefully about what we want to accomplish before going there. Jonathan and then Martin.
Right. Looking at the quoted part of 4594, it seems as though this behavior of remarking to 01 might actually be compatible with the current use as the least effort code point. But I would need to read that in more detail to be absolutely sure about that.
I will simply +1 your remarks, Jonathan. Martin?
Martin Duke, Google, no hats. I would say at a minimum, we would want, I mean, assuming that this is in fact an update that, I mean, not using the IETF word, but in fact, if 4594 has been superseded by other documents, then writing it down here is useful, just as a matter of having text, leaving aside all the technical document status questions. I will also note that 4594 is informational, so if we decide to open up the box, we could just update it.
Mm-hmm. Yeah,
and help clarify things.
I'm just more concerned that one of the things I definitely do not want to do is announce that any and all modifications, 4594 is over any and all modifications, this draft is going to do it. I think that would be a major mistake. So I want to proceed with great care here, make sure we understand what has to be done and do it and do approximately the minimum necessary.
And Gory.
Yeah, my question simply to our document shepherd. Are we just going to try and take input here and then wrap the document up? Is the working group last call heading towards completion?
Yeah, it sounds like we need to address this one question and then confirm that all the working group last call comments are addressed for some short amount of time, and then we'll be able to forward to the AD.
Thank you.
I don't know how soon, if I step down and I can change the working group shepherd to David. Gory is conflicted, so.
Yes, it will have to be me. Okay. Okay, Martin.
So I'm sorry, just to belabor the point a little more about 4594, like, I agree is not in scope to like revise the way that DSCP works in any way in this draft. That said, if there's a discrepancy and we can just update it with like 4 lines of text, does that really open Pandora's box?
What you proposed is well aligned with what I have in mind. Figure out what is a small amount of text we need to write to get consistency of 4594 with the current state of diff serve and declare victory.
All right, I think we're in agreement. Thanks.
Okay, now. Okay, we get to do this the hard way. So, Greg, which deck is next? Interop or NQB? NQB. Okay, I have to go do something. Left meta double click. Give me a minute. There, here, do that. Yes. I think I'm not sure which screen it is. Hang on. go close a bunch of windows I don't need here. And we'll see if we can make this work. Nope, that one. It might be that one. Hang on. Okay. Bingo. All right.
Great.
I think we got it working.
All right.
Now,
thank
you're
you.
going to have to, now, one of the things unfortunately has happened as a result of this is the left-handed double click means I can't watch the queue. So, Wes, you're going to have to watch the queue. I see Mike Hurd in the queue. You want to say something quickly, Mike?
Yes, your volume from the room is very low to the remote participants. Thank you.
Okay.
I'll speak up.
Greg, you want to start speaking? And Mike, you want to let us know if you can hear Greg?
Test 1, 2, test 1, 2. Is that loud enough?
But I can hear.
I can hear you.
All right. All right, update on the NQB draft. Go on to the next slide. So the status here, the last published update was the draft 10, which came out on March 4th. It's not been an update since then. Milestone here is to submit this as standard RFC by, proposed standard RFC by September. And what is left to do? Next slide. Turns out that selecting a diff script code point for to recommend in the draft that can reach consensus amongst all the people in the working group has been more challenging than maybe I anticipated it would be. I think in part because the goal of this is to encourage and enable its use end-to-end from across the internet, from senders to receivers. And there are an awful lot of existing practices in place around diff-serve code point in different networks. And finding a single recommendation or a single set of recommendations that everyone can live with has been challenging. But currently, what we have in the document, just as a refresher, is that the recommendation for applications, if they comply with the NQB description, is that they should mark their traffic with the value 45. And then on the network side, networks that don't support the PHB should treat NQB traffic as default, but should preserve the marking distinction. So if the traffic passes through their network with that marking distinction intact. And then the third major bullet, networks that do support the PHB, things get more complicated. So they must maintain the marking distinction, but they should not send NQB marked traffic or NQB traffic as 45 across interconnections. Instead, they should use the value 5 across interconnections. And if they're sending traffic across a customer access network link, so into a customer's home network, for example, they should use the value 45 there. And that involves remarking in that ISP network between the values 5 and 45 in order to make all that work. And that's where, on the next slide, that's where there's been some discussion. Well, actually, before I get to discussion, the rationale for that was presented at IETF 110. Font is probably a little bit small to read on the screen, but the idea or the rationale for the value 45 is that there are hundreds of millions of Wi-Fi networks around the world today that will meet many of the requirements for the NQB PHB today with no modification, no reconfiguration, nothing. If we choose a value that's in the range 32 to 47. So hence the value. Originally, we're using the value 42, but now 45. That is a significant incentive for adoption of this marking, that there are networks around the world that today will go a long ways towards providing NQB treatment for packets that are marked with the value in that range, the value of 45. And since, and that's again talking about Wi-Fi links, applications that are running on Wi-Fi clients, there is no opportunity for a network operator to remark that traffic from when the application generates it until it crosses the Wi-Fi link in many cases. So, so that's a very valuable property to have for the application recommendation. That again, it will get NQB treatment more or less and on many networks. Now, the rationale for the value 5 came about maybe, I guess, right before IETF 110 must have been, that there's at least one network, one transit network, large network, that that network operator said, hey, if you want us to carry traffic across our network, treat it as default and not remark it, maintain your marking distinction, not bleach it effectively, it would make our lives a whole lot easier if you chose a value between 1 and 7. And so it seemed that meeting that middle requirement on the previous slide of networks that don't support the PHB, carrying it through with the marking distinction intact would be advantaged by choosing this value 5. So we came up with this compromise of 5 at the core, 45 at the edge, and the requirement on the ISP in between to do that remarking. All right, now next slide. So the comments recently on the list and also some off-list discussion point out that there are folks that are not so happy with that recommendation or set of recommendations. First, there's an interest in ensuring that end-to-end traversal of unmodified DSCP remains RFC compliant. So in other words, this draft is the first drafted in the RFC series that would effectively recommend that all networks that want to support it do remarking. Whereas previously a network that just passed diff code points through end to end would be complying with all RFCs. So, so that's one concern. Second one is an interest in just minimizing the complexity. Some networks have said, hey, it doesn't matter to us, this value, 5 or 1 to 7, why can't we just keep it 45 all the way? In particular, a lot of ISP networks peer directly with application providers, and so there's not a lot of traffic that's going across multiple networks, going across transit networks, and it's unclear really what percentage of transit networks would prefer that value 1 through 7 to begin with. So why can't ISPs just use 45 end to end and make that the recommendation? For others, again, using the value 5 would make their lives easier, and receiving traffic already pre-marked by 5 into their network would make them happy. Sarah, comment?
Yeah, so I'm sorry, I'm behind on the list, so maybe this was covered there, but so marking 40, so the naive and stupid way to remark is just to bleach 3 bits,
right?
And do we have like, are there provisions against that in the draft? And if so, do we think that's realistic given what we know about the community?
I didn't quite catch the last part of that question.
And assuming that the draft is like, well, let me put it this way. I think the draft should say, thou shalt not just do this for everything greater than, what is that, 8, to just bleach these bits. Like actually check for 45 and replace it with 5 and vice versa, not like apply a broader filter. I think that would be wise. But secondly, like based on our knowledge of the community, if we write that down, will that actually be observed? Or by setting this up, are we just going to create bleachers that ruin everything?
Yeah, well, the draft definitely does not recommend just bleaching the top 3 bits for all district code points. It specifically talks about mapping 45 to 5. As to whether defining that in this draft encourages the other behavior, I'm I'm not sure if I could predict.
Sure, fair enough. That's fair.
I mean, we could make some statements around that, I suppose, that that this is recommended specifically for just kind of hammer that point home, I guess, that it is not intended to mean that bleaching the top 3 bits is the desired behavior for other code points. We could
Yeah, I
have some
mean,
tips on that.
you know, like, I mean, to the extent that the first concern is valid, I think that's where it really is, like that we're going to create collateral damage. But I'm not an operator. Maybe, you know, others could share their perspective on that. But thanks.
Okay. All right. Anything else in queue? Yeah. Okay. Yeah, sort of as part of the discussion, I guess I'd invite other operators who may have opinions on that to chime in. The last point that was made, this was off list, was, or maybe on list at one point, was that some applications might be hosted in locations where they're on a network that would prefer the value 5. And so is the recommendation to use 45 for all applications the right recommendation? I mean, it currently is a should, it's a recommendation. So local practices are allowed to preempt that, but there might be some value in actually having a recommendation for the value 5 in some certain situations. What those exactly get written as, I think, is the open question. Anyway, next slide goes on to a proposed compromise. I don't know if this meets everyone's requirements, but the idea is to change the recommendation to recommend 45 across interconnections, so 45 end-to-end, and then have language that says, in some cases this may not be the ideal code point in some networks, but if remarking is necessary, recommend the value 5. So we still have 2 code points that are identified in the draft, and some hopefully consistency, at least between networks, that there's traffic is either 45 or 5 NQP traffic. But here the onus would be on the receiver of the traffic to remark the value 45 to 5, unless they have some agreement with their interconnection partner ahead of time. And then the bottom bullet on the application guidance, update that, and to mention that in certain cases, 5 might be preferable, in providing a recommendation there, and not just leave it totally open to the application developer, but recommend that value 5, but also recommend that they consult the network in which they're deployed in order to make that decision.
David is in the queue, and then Gory.
Right. So this is David speaking from the floor. Wearing no hat, but as one of the authors of the original DiffServ RFCs. Let's see. Oh, I almost basically have to put the mask into the mic. Okay, so David speaking from the floor, wearing no hat, but as one of the authors of the original DiffServ RFCs. The fact that we need two recommended DSCPs continues to bug me. And I also think that last bullet there is unacceptable, period. And so I guess I go back and start wondering about, so what are we trying to do here and how did we arrive here? This started out as, let's provide a PHB for traffic that is effectively default, but doesn't build a queue, and therefore we can handle that separately.
Right.
So far, so good. Then along comes Wi-Fi. And we can't do that on Wi-Fi, at least as I understand, not without completely changing all the Wi-Fi deployed gear. So in order to make this work over Wi-Fi, we have to do something else. And 45 and the mapping into ACVI is not default on Wi-Fi. It's something else.
Right.
And I guess what I'm wondering is, given what we discovered on Wi-Fi and the importance is working right on Wi-Fi, should we go back and rethink this and say maybe equivalence to default was not the right goal for this? The right goal for this was to carry the NQB traffic identified as NQB and assign it separate priority and resources where needed, for example, Wi-Fi. But right now, I think what's on this slide is a fudge, and I would like to see something architecturally clearer and cleaner. And I originally tried in the list to say, gee, can we just use 5 everywhere? And the answer is no, has no chance working on Wi-Fi. So now I'm effectively asking, can we effectively use 45 everywhere and work through the consequences of the resulting design change? Because I will admit that this is a design change to where the PHB design started.
Yeah. I think
And I don't expect an immediate answer because I put you right on the spot, up on stage in front of us. So it might be that this is, I've said my piece and we need to think about it and bash it on the list, but something is still bothering me very much architecturally about this situation.
I think I would argue for the recommendations still being, or continue to be, that the NQB traffic is treated at the same priority as default, as the preferred behavior. Maybe we could soften that to say, in some networks where this is difficult and feasible, some, pick your word, it's okay to treat it with higher priority and blah, 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 some protection of that. Right? The idea here is not to create a high priority path, right? It's to create a path for sparse applications that would like not to be subjected to latency caused by QBLM. Right?
We should have a discussion in more detail on the list because the glass half empty view of that is independent of what the original goals may have been. This does not work on Wi-Fi and hence does not work at all unless you create the high priority path, at least there, raising the question of should we admit that the right thing to do is high priority path everywhere?
Yeah, well, to say it doesn't work on Wi-Fi is a little bit strong. I mean, it's the default behavior of existing Wi-Fi gear to put it in high priority queue, but with some configuration changes, most Wi-Fi access points can map the value 45 into best effort. Some of them with code changes, some of the more recent ones, you can actually create a separate queue in best effort and map the traffic there. So yeah, it's more the existing Wi-Fi unmodified where the high priority aspect sits. So
Let's go to Gory.
Yeah, I was going to say thank you ever so much for sticking at this. What I see here with no chair hat on is definitely much better than what we had last time we talked about this. Using 45 everywhere and allowing 5 as a difference within a particular diff serve domain seems a much more straightforward solution to this than the original one we had. So this looks promising. Thanks for working on it. My question would be, has Rudiger seen this particular flavor of combinations? Can we channel him a little bit, because I know he's not able to join the session at the moment, and he's played a good part in it. Do you have any feeling about what his sensitivity might be on this current proposal?
I think he wasn't totally happy with the wording of it, but I was just trying to channel him.
Right. Yeah. I'm just judging what's going on. Just aware that there's another person in the room who's helping to try and get this right. Thanks.
David?
Yeah, this is David back on the floor, still wearing no hat. Something Gory said might provide a way out of this, which is we are circling something by trying to recommend both values. And I heard Gory say the magic words local use. If we recommended 45 and then discussed the necessity in some networks of local use of a different DSCP, which is completely consistent with the diff-serve architecture and doesn't require us to ask IANA to do anything. And then discuss that perhaps 5 could be that local, somewhere in there, fitting this into the notion of local use, and a network operator can use DSCPs other than 0 for anything they want it for, might get us something considerably cleaner and acceptable.
Mm-hmm. Okay.
Yeah, we'd have to square on what local use mean with an IANA assigned port, but we could assign it for that particular purpose of local use, and we would be able to do the various things. Good thing to drill into, I think.
Yeah, I mean, so Gary, I don't think I agree with when you went for defining, but I think the diff-serve concept of local use and being able to do whatever the operator needs to do with DSCPs in her own domain might provide us a way out of this maze.
Yeah, and
yeah.
Let's continue to discuss this. And my comment on Rudiger is simply to say that if you really are interested in this, please join in and send comments to Greg. Join in the discussion. There's a lot of discussion going around this. It's not just Greg coming up with a new solution each time. And I'm sure we'll get there pretty soon. Thanks, Greg.
All right. Thanks. Yeah, I will, I think after the meeting, send a post to the mailing list with some more of the comments that were discussed off list as well, to make sure everyone is up to speed on that. All right. If there's nothing else on that.
Any other comments?
Jason +1 to the local use on the chat. So.
Oh, so Jason +1, the idea of using local use to solve this one. Oh, good. I'm not completely crazy this afternoon. Okay, cool. All right, so now we need to do hackathon, right?
Yes.
All right, hang on a minute.
All right, so for those of you who attended the conclusion of the hackathon yesterday, these slides will look very familiar. I had intended to include a lot more new data that we've collected today, but time kind of got away from me. We were working on.
We'll take late breaking news any way we can get it.
Yeah, so I did do some updates, but the graphs will look pretty familiar if you've seen them before. So this was the first L4S interoperability event that brought together a bunch of different implementations of L4S and both network equipment as well as congestion control implementations and TCP receivers that can feed back using the accurate ECN functionality. So the drafts, everyone in this room is probably familiar with those already. The 3 L4S drafts, which have completed IETF last call, as well as the accurate ECN draft, those ones we've been testing in the hackathon. And I guess the last part, everyone here is probably familiar with that too. Involves the sender, the bottleneck, the receiver. Next slide. So our plan, so the hackathon, strictly speaking, was just Saturday, Sunday. We came in Friday afternoon to begin setup. We have quite a bit of equipment. If you haven't gone into the hackathon room, I encourage you to take a look over there. Actually, this evening, after this session, is the hack demo happy hour. And so please come over to Liberty A, 2 doors down. Take a look at we've got 5 tables set up in the front of the room with all sorts of gear stacked up on them. Cable equipment, Wi-Fi equipment, some network emulators, and a bunch of clients. What you won't see directly in the room, but right outside the room in the back are 2 large racks of equipment that are the cable CMTS equipment, the head-end equipment that implements L4S as well. So in terms of the plan, yes, we were there Saturday, Sunday, working on testing. We've been there this morning testing and collecting more data, and we continue tomorrow. So we'll be there all day tomorrow, continuing different permutations of gear and combinations of equipment, et cetera, et cetera. So next slide. In terms of the implementations that we've got, on the congestion control side and the sender side, we have the Apple Quick Prog implementation, TCP Prog, Google's BBRB2, NVIDIA's GeForce Now, which is a proprietary UDP implementation, and Nokia's real-time Prog, which is integrated with their codec directly. On the marketing feedback side, we've got a couple of Quick implementations, Pico Quick and Apple Quick, and doing interoperability testing there. And 2 TCP implementations that do accurate ECN, one from Google, one from FreeBSD, and then the NVIDIA GeForce Now client. Next slide. On the bottleneck link implementations, we have 7 of those that are there at the hackathon. 4 of them are low latency DOCSIS, 2 cable modem chipsets that's doing the L4S functionality in the upstream direction, and then 2 CMTS implementations that are doing it in the downstream direction. 2 Wi-Fi implementations, one from Google Nest, the other one from Nokia, and then also a 5G/fixed network emulator that does a full RAN emulation as well as doing the L4S functionality. 6 of those 7 bottlenecks implement the dual queue coupled AQM from the TSV working group draft. And one of them implements an L4S aware FQ coddle. And next slide. In terms of combinations that we've tested so far, I'm not going to go through the whole list, but I just to try as many combinations as we can. Some a single congestion control implementation using a bottleneck. In other cases, it's pairs of congestion control, or even like 3 in one case, congestion control implementations simultaneously sharing a single bottleneck. Each of these, there are all sorts of different configurations of, particularly the DOCSIS, traffic rates, whether queue protection is on or off, marking thresholds and things like that that we've been testing and looking at results on that, and more will come. So next slide. Here's a snapshot of some of the results, probably not too readable from the back of the room, but actually I may have to look here. So this is, for comparison, classic traffic in the upstream on DOCSIS. And you can see on the top a latency time series, and on the left in the middle, the CCDF of packet latency, and on the bottom is the throughput time series. And circled is the P99 and P99.9 packet delay variation statistics. So with classic traffic, so this is cubic, P99 packet delay variation of 30 milliseconds, P99.9 of 125 milliseconds. And then next slide.
Okay, we'll go to the next slide. Things pay most attention to, because there's a lot of detail in these slides. Pay attention to the CDF on the left side of the slide, and pay attention to the blue circled stats on the right side of the slide.
So with the L4S implementation, P99 packet delay variation now 9 milliseconds, P99.9 now 10 milliseconds. And that packet delay variation is not just queuing delay. That includes the media access delay on DOCSIS. So in this case, it's doing the request grant mechanism on the upstream. So there's 4 or 5 milliseconds of delay variation just from, sometimes even more delay variation just from the media access on that.
And the other thing to do is the tool that generated this helped by normalizing and tried to confuse you. Notice on the CDF on this slide is done at about 17. Back here, the CDF is out to 100 and to what, 150, Greg?
150, yeah.
Okay.
Yeah.
Not quite an order of magnitude. Doggone impressive.
Yeah, pretty darn close, yeah. And then the next slide, similar result for downstream. Move on to that one.
Bingo.
And unfortunately, we actually realized after we put this data in the slide that the classic AQM configuration, actually classic AQM implementation on the CMTS that was used for this testing had a bug. It was a bug that actually was discovered earlier, but the correct firmware image didn't make it into the hackathon, unfortunately. So that's why we see the incomplete utilization of the downstream channel here. It doesn't go up to the 200 megabits consistently. There was quite a lot of packet loss at the beginning, which kind of tanked the classic TCP performance. But on the latency side, that made the latency actually pretty good for the classic flow after that initial startup because it was underutilizing the link. But still, we see 99th percentile PDV of 55 milliseconds and P99.9 of 96 milliseconds compared to, next slide, with L4S, P99 packet delay variation of 1.1 milliseconds and P99.9 packet delay variation of 7.8 milliseconds. So, and again, and great throughput as well. So, just one snapshot of kind of work in progress. Obviously, a lot of testing going on in different conditions. These were some graphs that we pulled out as being kind of nice illustrations. So, in terms of the participating organizations, so 15 different organizations participating that brought gear or implementations of congestion control and or otherwise facilitating the testing. And then the next slide, number of people involved, 32 folks altogether who've been involved in the testing. So definitely a success. And we started having discussions about next steps, potentially another Introp event at London. I think it's a TBD, but if there's sufficient interest, we'll try to organize one there. Any questions or comments?
Can we have a round of applause for all the people who did the hard work on this?
Yeah, thanks. Yeah. All right, thank you.
Okay. Yes, my cheat sheet says we're not the user ports for experimentation draft. So, okay. Wes has decided to pretend to be Joe, and I think we've talked to the AD, and we think we know what we want to do with this. Okay, but first we probably explain what it is before we explain what's going to happen to it.
Yeah, so Joe is on vacation and he didn't want to spend his vacation in Philadelphia with us. So I'm going to represent the document for him. And it's a 4-page document. You can probably skim through it yourself just as fast as I can survey it. But the essence of it is that it's asking for 2 ports to be assigned for experiments from the space of user ports. The reason being there are already ports assigned for experiments in the system range, but that doesn't work for everyone because you may need root access on some systems in order to use those ports. Whereas the dynamic ports also don't work for some people because those can be blocked by firewall policies in some places. So getting some ports from the user port range for experimentation is felt by the ports team, which I work on with Joe, to be a pretty helpful thing because a lot of times when people have these protocols, they come and ask for port assignments, even though they might not be ready to deploy widely. And so the typical response that we give them is to try to use dynamic ports. And if that isn't going to work for them, then we don't have any kind of place like the user ports that we can send them to use some experimental ports without needing a IANA assignment. So that's really all there is to this, just asking for 2 more ports to be assigned for experiments. And there's one extra bit that's of interest in terms of answering the question of how do you avoid conflicting use of those 2 ports. And there Joe has basically borrowed the idea that we have in the TCP experimental options of having a 32-bit experiment ID that you can get first come, first serve. So nothing really required there in order to get an experiment ID allocated from IANA. And you can use those as a way to put a cookie into your packets and or magic number into your packets, and basically not have collisions of different experiments using those two port numbers. So that's all there is to this. Lars.
Lars.
Hi, Lars Eggert. So you stick those 32-bit values into a TCP option, I assume, right?
So it's, to be blunt, it's not my draft, but I actually, in reading it, had the same kind of question about how specifically to use those 32-bit values, because you could think it might need to work differently for UDP, for TCP, for other protocols. So I think that's something that Joe probably needs to address more deeply.
Okay. So I'm wondering if you stick him for TCP, if you stick him to a TCP option, and you already couldn't use, you know, dynamic ports because they didn't go through your firewall. I wonder if that firewall lets like unknown options through.
Yeah, I mean, my reaction to that was to one possibility would be just stuff the experiment number, magic number, at the start of the payload of the experiment. Mike is in the queue. Go ahead. Oh, okay. Actually, Lars is headed back to the mic.
My reading of the draft was that it was to do exactly as you said, David, to put it at the front of the payload. And I might note that this is supposed to be transport agnostic, so it wouldn't work to put it in a TCP option. That wouldn't work for UDP, for example.
So you put it in front of the transport payload or the IP payload?
Transport payload.
Okay,
In essence, you start off with TCP. You start off the stream with this magic number,
Right.
and if you've got a protocol that thinks it's doing framing on top of TCP, this is a good thing to put in the frame header.
So that means you can't experiment with stuff that is a library or something, right? Because if you don't control the byte stream directly, you can't put the number there. So I guess I'm sort of wondering about the usefulness of the number because it limits some experiments. Is there an option to not do that and just use the port?
Martin Duke, Google, no hats. Although with a hat, I apologize for not thinking of this because you sent me the draft and I had a warning of it. But yeah, the middle box, I mean, so the like payload problem also is a middle box problem. Like, as everyone knows, it is like extremely common to chop up the payload and repacketize it. And all the dumb middle boxes in between will be very sad.
Mm-hmm. Okay, so we're going to start an adoption call on the list. Probably figure out running the adoption call during August and see if we can get more discussion going on how to use the how to use the experiment ID. I believe that's it for that draft. Sure, why not? Can I see show of hands? How many people have actually let me get the slides back up. One thing at a time. Okay. This draft. Raise your hand in the room or on the list if you've read this draft. I see maybe 5 people in the room have read the draft. Maybe. I have one person with a hand on his head. I can't tell whether it's raised or resting. And so, okay. I think we need to run the adoption call on the list, and we have more discussion of appropriate use of the experiment number, magic number, cookie, whatever on the list. Okay. Let's see. No, wrong button. Hit that button. Do, 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 do. Lewis, are you online for port forwarding, enhanced port forwarding with CGNAT?
Yes.
Yes.
Can you hear me?
Yes, we can. Go for it.
Are you going to control the slide for me? I mean, you flip the slide for me, right?
Yes, I will advance the slide. Just say next slide. You get next slide.
Thank you. Thank you. So my name is Louis Chen. Today, actually, I'm going to I'll give you a kind of, a draft which solving a trouble which we have in NAT 444 situations. And this is a long-standing problem for wherever TCP. If you want to do a P2P connections with TCP, you'll face some trouble when you do a CGNet or NAT 444. Next slide, please. Okay, so the problem statement actually is, well, when we have the NAT 44 or NAT 444, with RFC 5128, it provides a method to set up a P2P connections behind any NATs, even CGNet. However, it only usually works for UDP because it uses a kind of a method called hole punching. But for TCP, this is a very low success rate. So normally, I didn't see people, the commercial product, they're using TCP for this kind of hole punching. Usually they use UDP. I think a lot of I see some game console, they only use UDP for the hole punching. And the problem with hole punching is they need a common third-party server. That means the both sides need a common third-party servers to exchange the informations. That become a limiting factors for this one to work. So the solution actually is, I hope it to, even under CGNet situations, NAT 444, you can host a service behind all these things, NAT, and even an HTTP service or SSH or SFTP, doesn't matter. But of course, it's not port 80 or 443, that kind of ports. But it will host a service just like that, and you can create an incoming P2P connections, either TCP or UDP in this case. Next slide. So this is the how a hole punching is working. So from the PC1, you connect to RG and CGNet, and there's a NAT 444 in this case. And then from PC2, if you want to have inbound connections to trust the PC1. So today, the only working mechanism is the hole punching. Hole punching has UDP hole punching has high success rate, but it really depends on two things. First of all, they need a common server to exchange the information so that they can punch the hole at the same time. That means there's a timing between the PC1 and PC2 send the traffic across the other side to punch a hole. And also, because of this one, the limitation, PC1, PC2, and common server, usually they belongs to the same entity. For example, it's a webcam server, it's a webcam kind of PC1, the PC2 is a software, and then the common server actually is operated by that webcam kind of providers. So in this case, in this diagram, because of the CGNet and RG in this diagram, it's difficult for TCP to actually being successfully punching, because the synchronization and also the time kind of synchronizations, and also the kind of some CGNet implementations or the RG implementations. So the TCP usually very low rate in this case. So here I'm trying to solve this problem with the next one. So next slide, please. So this is the kind of function I implemented in the CGNet. Very simple. It is just allow a kind of TCP UDP incoming connections. The only thing is just a knob actually. Just do not change one of the destination ports when it's going incoming, which I'm going to illustrate in the kind of diagram in the next slide. And it allows actually the chain of forwarding of the same destination port from the CGNet to RG and hence to the end device. Next slide. May I give you a kind of a demonstration on that one? Next slide, please. So this is actually a kind of lab I've testing this one. So it's under NAT 444. If you see this one, there's a PC1, and then between PC1 and RG, which is the home gateway, you have the network is 192.168.20.0. And then between the RG and CGNet, you have a 1.0, 92.168.10, right? That networks. And then you have the public range, which is here, the public range, the port range is assigned for this particular RG. So the public address here is 201.1.1.10, and the port range assigned is 1024 to 1055. So usually the how the PC1 allocated the port, you're using UPnP or NAT-PNP from RG, and okay, I reserve the port over there, either TCP or UDP port there, and then it will the port will forwarding to the PC1. That is normal operations. Here I add an additional procedures is I need it to detect what port it can be used. So for example, here in PC1, it will send a kind of detection via third-party stun servers. There's a lot of stun server in the network right in the internet right now. You just detect using a stun server. It will tell you about, okay, now you are using this IP address, public IP address, and then the port number is 1024. Okay. Once you know that 1024 is available port, then you actually using UPnP, step 2, using UPnP to reserve 1024 this port in the RG. So anything sent if 1024 for the PC1. And then in CGNet here, this is something, the new function, the knob I need to implement is whenever it sees some incoming connections, the 1024 that port, I mean the port number actually assigned to that RG, or I mean the range of the port, right? It won't modify. It will just keeping the port at this, not change in this case, because there will be other sections actually created under CGNet. You just make sure that this port number will not change for incoming, right? And then from a PC2 here, it original packet sending trust this public IP address 201.1.1.10, which is going trust the CGNet, and then with the destination port is 1024, which is TCP port, for example. And it will be actually going trust the EIPF, which is, sorry, the CGNet, and with the EIPF functions, this one will unchange the port. Okay, usually the port will change because of CGNet functions, but this port now isn't change. When 1024 port actually reach the RG, okay, this 1024 just using just normal kind of port forwarding, right? Just a UPnP, it will forward the PC1. So in this case, PC2 can connect to PC1 with a TCP in this case. So it can be HTTP, it can be any kind of TCP services. It also can work for UDP as well. So this is a very simple, easy method to actually make it work under CGNet as well. Because right now, wherever we have CGNet, this kind of hole punching become a lot of troubles, and a lot of like BT is not working actually. I mean, PC1 want to sitting something is not working today. I mean, because it's under two nets actually. So next slide.
Sorry, could I ask a question?
Yes, please.
What is you're saying about registering or something? What's actually causing you to have this behavior? Because if you have this behavior always, aren't you giving up a lot? If you're actually making the CGNet endpoint independent for everything, then you're losing all the capacity of the CGNet.
You mean EIM? You mean EIM enable? Do you mean EIN enable, or
how does the CGNet know that it should have this behavior?
You turn on the knob actually, saying that for this this address range or this user, whenever assigned from this IP pool or whatever, it will have this behavior. That means it will allowing incoming connection when you see that, okay, there is unknown connections, unknown sections arriving in the CGNet, and that's pointing to tossing to RG that directions. Then it allow the sections, it create the sections like this way.
Okay, so because I didn't understand that from the draft at all. How that part, or you didn't explain it. It wasn't present, I think, in the part for saying that you need to have some configuration step there.
Yes, that's a function. This is why a new function is not something actually a procedure, and you need a knob to turn on in the CGNet to allow incoming like this way. Otherwise, it's just looking at the section table to see whether that section is already created or not, right? So right now, you need a knob to actually enable this function so that it will allow this one to pass through. All right?
It sounds like you actually need a config per RG to say whether the RG is offering services, and hence the CGNet must behave this way.
The RG do not need to have. I mean, this is normal RG. Any RG today will have the UPnP supported. It has EIM supported as well. If you look at the RFC, those are previous RFC. There's called function called EIM, endpoint independent mapping. All the RG today have this kind of function already there.
So you're missing the point.
Sorry?
You're missing the point. What Magnus pointed out is that there is a current CGNet behavior, which is shown on this slide, differs from that current behavior. How does a CGNet know whether to do the existing or the new behavior? And it sounds like the answer is it's a per RG configuration of how the CGNet behaves.
Not really. Okay. So, first of all, the RG is independent, right? RG working so long as support EIM, it will work. The problem actually is CGNet, how to implement it. So if the CGNet implement in a way that it is following the RFC with the EIM, all these functions, okay, it's easily turn a knob on and then enable these functions, which I call EITF, and that will work. The RG, no need, because I tested in lab already. Myself, I use different DDVRT or OpenDRT, the kind of open source, it works. Okay.
Yeah, I understand it works as long as you put the CGNet in the endpoint independent behavior. The problem is that no CGNet will run in the endpoint independent behavior, because then you lose the whole point of actually being able to run sessions, because your address usage will be
endpoint behavior is usually for outbound. Okay, from PC1 out going to PC2, that direction is EIM, right? Right. This is the outbound corrections. It's called EIM. But now I'm talking about inbound direction from PC2 to PC1. Then the new function is called EIPF. That is different directions.
But I mean, either this is no filtering or I don't quite understand the story, but let's go on.
Yes, I think maybe, there's a lab can demo that one actually. But I think I don't have time to do a lab demo here, right? So you can verify this one. Okay, next slide, please. Sorry, next slide. So basically, I mean, there's a difference between you have a public IP address, the RG point of view, right? From RG point of view, you have all the usable ports from the 0 or 1 to actually 65K. But usually with CGNet today, there's usually pop-up allocations. That means you allocate a certain port range for a particular private IP address. You specify a range, for example. Depends on the port range, right? Around that one, and sometimes the port range may be even single port, right? So, but doesn't matter for this kind of the draft. I don't care whether it's a PBA, a port range, or a single port. You can have multiple discrete port allocated is also fine, because I can just repeat the procedures to allocate different ports. For example, this is 1024, maybe 8,000, and then now next one make 9,000. So long as the behavior is correct behaviors actually. So here it just try to in here, if 1024 to 1055, then it's actually picking up one of the port within this range, and then we detect one of the port and then just allocate that port to itself, right? So now CGNet actually constantly allocate TCP port and UDP port same range to the same private IP address. Next slide. This is the last slide. That means for the service provider, the CGNet provider, there is another things that I put in the draft, say that, okay, you can let the user or the RG, okay, to use the HTTP kind of method to retrieve the IP, the public IP and then the port, or the public IP and then the port range. So here I use a very simple URL kind of things. just using HTTP, you can integrate it in your software in the RG, okay, to get the port range, or you can use the web browser in your PC just to get your public IP address and then the port range. Today it's easy to get a public IP address, but you cannot get the port number actually present in the public, the networks. For example, this port, maybe you can use it for BT, okay? This public IP address and the port number you can use for BT, and they have manually enter into your games or the BT software. You can do that this way, okay? So this end of the slide. Any questions?
Dan, go ahead.
6 is not described well in the internet draft. In fact, I didn't see a discussion of it at all. And I'm confused the order of events for getting the punch through to happen and the incoming port to happen. So slide 4 or 5, I forgot now, but the slide Magnus commented on seemed to show after the hole punching and the RG communication and stuff had occurred, but there's no discussion in the draft of how that order happens. If it starts with PC1 and goes to RG, and then the RG is what signals the CGNAT, or the PC is what signals the CGNAT, it would be great if the internet draft described those sorts of things.
Yeah, in fact, actually, you can see it like, a series of port forwarding from, for example, if you know port forwarding, right, in the home gateway. So if you allocate 102 for port, whenever traffic go to 102 this port will send to PC1, okay, you register this one. Between RG and CGNet, there's no control plane protocol, there's nothing. So here, the reason why I designed it this way, I don't want any kind of control protocol running between all these entities, PC1, RG, and CGNet. There's no control protocols. That will be make it more scalable in real deployments. So here, actually, the 102.4, actually, you can receive it like this. If I see 102.4, this one, I will send it to RG, actually, because this one, whenever you allocate, you have a private address, which is the 192.168.1.11, which is assigned. When this one actually 1.11, this one assigned to the RG, immediately actually there's a kind of public IP address and port number, port range will be allocated. This port PBA in this kind of allocations, and this 102.4 actually is part of the port number. Actually, can be forwarded towards the RG that portion. That means this AIPF only enable the things actually anything within 102.4 and 105.5 is just forward to this RG, to this 192.168.1.11 in this diagram. This is just make it blind and just forward to the whole, whatever things forward to this guys only. So you can see this is like a series of port forwarding only. Just from the PC2 to PC1 directions is a series. I'm not sure I answered the questions, but I hope it makes it clear.
Yeah. I think I'm going to call time on this question. Ought to be taken to the list. If you think the working group ought to work on this draft or something like it, please post the list or come talk to one of the working group chairs.
Okay, sure. Thank you.
Thank you, Louis. Click there. Heng, are you online?
Can you hear me?
Yes. Keep speaking.
Yes. Thanks. Hello, this is Peng from China Mobile, and it's my pleasure to introduce the work of computing-aware networking. We had CANBOF in IETF 1.3, and there are some questions related to the upper layer protocol. So that is the reason why I'd like to present this work to see if there is any comments from the WG. Next slide, please. First is the motivations. Computing-aware networking aims at computing and network resource optimization by steering traffic to appropriate computing resource, considering not only network metric but also computing resource metrics and service validation. It is to solve the problem of the closest is not the best providing the best user experience of low latency, high reliability, and stable service experience when moving to different areas based on the increasing development of integrated computing and network infrastructure, such as CDN and edge computing. Next slide, please. So in the CAN-BOF, the use case showed the necessity of steering traffic considering more factors besides the network status. And we also analyze the gap with the DNS and the load balance. The DNS was not designed for the dynamic scenarios with fast changes of the service instance. And caching are old, and it should also learn computing status are the additional problems. And the load balancer should also learn about network status. So we also had two potential solutions. One is a dynamic anycast. It's based on the edge routers get the computing metrics and select the service instance. And there's also an on-path load balancer. It uses centralized coordinate with decentralized load balancer and also learned the network status. The conclusion is that the BOF was successful in agreeing that the use cases are important, while the solutions and next hop is not clear. Okay, next slide, please. So to promote this work based on the BOF discussion, we collected 36 issues in the BOF discussion, gave the responses, and update the draft accordingly. And I select some of them that might be have the relationship with upper layer protocol. First category is what the relationship between CAN traffic steering and the service deployment, discovery, and upper layer protocol. Here we got answer is that the whole process includes service deployment, discovery, and traffic steering, and CAN assumes the service have been deployed and discovered in multi-edge sites, aiming at traffic steering. On the one hand, CAN should coordinate with upper layer for service deployment and discovery. On the other hand, the computing metrics collection in CAN will also benefit them. And the second issue is about the relation between CAN and Auto. So Auto solves the problem of service instance selection as an off-path solution, such as it is like the DNS and the load balance, replies for the applications or service before traffic deliver might not be optimal or valid after the handover. So more details are needed of Auto, including some extension to support multi-deployment, quick interaction, integrate more performance metric information. And here are just the issues about the upper layer protocol. More issues could be found at the GitHub. Next slide, please. And we also had updates the 3 key drafts of problem statement, use cases, gap analysis requirements, and the diecast architecture, and also submitted a new draft of computing resource modeling to describe the possible modeling of the computing resource and usage in CAN. As a discussion after submitted this draft, the instance selection mechanism should be another item based on the modeling, which we will continue working. Next slide, please. So the next step is refine the draft, and we also welcome anyone interested in the work or give some comments for both of the network and the draft. Thanks.
Gory, go ahead.
Yeah, I saw this work appear in the proceedings of the last meetings, and it looked like a routing area. Most of the issues appear to be routing related. So what is it specifically you're asking the transport people to do? Where's the transport part of this problem?
Yes, we had other issues such as maybe the service deployment or service discovery for this, not requiring a very low latency response. So may use upper layer protocol because we get the issues from the community. So we'd like to clarify the work and also find more comments from the layer 4.
Okay, I didn't get from that what you wanted the transport area to do. I enjoyed your talk, so if you want to follow up on list, I think that would be a great conversation on the mailing list.
Yeah, thanks.
Martin?
So I think in my understanding of thinking of this is, Peng was told to go get some feedback from the transport area, and he's doing that. It is true that Alto is a transport area. I'm not sure there are a lot of Alto proponents in the room, unfortunately. As the responsible AD for Alto, I will say that I think there are a few concerns on how that's going, and there's certainly similarities. There's a fair amount of concern about the speed at which you want to do these updates. And the other issue with Alto is that it has not really been deployed very much. And I think, I personally would like to see some assurance that we're not going down that same road again and doing another application level Pathfinder that no one deploys. So I think on your first slide you had use cases are important, and that's certainly the case. This is not a research project that somebody actually wants to deploy this at scale to real users. Thanks.
Yeah, thanks. We have addressed some relationship with autos in the gap analysis draft, and I think it might be keep opening for more discussion. And the discussion also correlated to the auto mailing list. Yeah, thanks.
Let's see, Tanji, go ahead.
Yes, Tenji from China Mobile also. Peng is my colleague. So I can answer the question from Martin about some use case about the things. Actually, this is some sort of real scenario for us. And also, if you attend the big 5G in the past May, there's a tier 1 provider talk about a similar concept. It's like a BYOD. Some compute will be provided by the mobile operator itself, or you even can bring your BYOD such that they put together and use this type of concept to select the best thing out of. So it's real. You can go back to big 5G to listen. So it's a real thing. Thank you.
Dirk, go ahead.
Yeah, hi, sorry, finally unmuted. Yeah, as one of the causes, apart from the update to the transport area, I think the linkage to Alto that Martin made was a good one, because it's if you look at the mechanism proposed, Alto is, and we described this in the gap analysis as an off-path solution, and CAN is proposing an on-path solution, which is why it's positioned in the routing area, and the lessons learned from Alto, I think, are very, very important to take into this, which is why we're focusing also in the gap analysis to look deeper at systems like Alto and to understand where, for instance, the frequency and the dynamics of the updates are an issue with off-path solutions like Alto, which is why CAN is proposing an on-path solution where these frequencies of change of instance selections can be much higher. And in some of the use cases, you can see those in the use cases, the frequency, the higher frequency is required, and it's one of the benefits that CAN is promising, at least as a solution in the use cases. So there is a relation to Alto in terms of the insights. in order to really prevent what Martin was referring to go down the path of yet another similar solution, which kind of like suffers from the same drawbacks. And I think that's why we're kind of reaching out to the transport area, because the ALTO work is being located and conducted in the transport area. There are a couple of possibly also transport protocol related aspects, which we haven't deeper discussed yet in CAN, but personally, we've in some of our own work, we've been looking into some of those issues that have to do with the existence of several service instances. How do you handle transport connection change really quickly? These may be things to come back to the transport area as well later on if this work progresses in the routing area. So it's another potential connection point. Thank you.
And Martin, AD.
I'm sorry. I'll try. I know I'm staying between you and dinner. I'll try to be brief. Right. So I'm like, my personal mission is to figure out what the status is of Alto in the real world, and I've not completed that mission. But I will say that, like, issue number one was designed for peer-to-peer, and that use case sort of imploded. They are trying to get over to CDNI and some other things that seem to make sense, and that draft is like just made RFC, so I don't know how that's going to go. Yeah, so I would encourage you to engage with that community and find out what their pain points have been in particular. And absolutely, if you have very specific transport questions related to, you know, metrics to use, transport style metrics, and so on, Alto and IPPM are not particularly well represented in this room, but are in the transport community and would have a lot of the knowledge points there. TSVG is open to TSVWG is open to you for certain kinds of transport expertise, and if that's what you need, then by all means approach the chairs, and you know, we'll do what we need to do. Thanks.
Any other comments or questions? All right. Peng, you want to have some closing remarks?
We will consider the comments and continue working on this. Thanks.
Okay. And with that, I think we're done. And on time. What a concept. Thank you all very much. See you in London. I need to go. All right, let's can that.